Okay, I want you to forget everything you think you know about math class. Seriously. Today we're not talking about boring, dry calculations. We're talking about a powerful toolkit, a set of tools for actually understanding the world around us. And you know what our guide is going to be? A sixth-grade math textbook. Yeah, let's dive in and see what we can find. This little conversation pretty much sums it all up. Monty's joke, it hits on a really crucial point. When we talk about big numbers, we're usually just trying to get a feel for the size of something, not the exact, down to the last person count. 10,000 paints a picture. It's about getting the idea across, not just crunching the numbers. I mean, think about it. From the distance to the moon to the population of your city, we are constantly swimming in data and information that just feels way too big to wrap our heads around. So how do we actually cut through all that noise and find what matters without getting totally lost? Well, the answer is in what we're calling our mathematical toolkit. It's not about being a human calculator. It's about having the right mental tools to organize things, to compare them, and ultimately to really understand the patterns that shape our world. So today, we're going to unpack 4 essential tools from this kit. First, we're going to figure out how to tame those giant numbers. Then, we'll look at how to find hidden patterns. After that, we'll learn how to make fair comparisons. And finally, we'll see how thinking systematically can help you solve pretty much any puzzle. All right, first up, let's go after those giant, intimidating numbers. The absolute key here is organization. We need a system, right? Otherwise, a long string of digits just becomes a meaningless jumble. And the main tool for this is something we see every day, the comma. That tiny little mark is an absolute powerhouse. It groups all those digits into chunks we can actually read. Thousands, millions, billions. I mean, without it, the distance to the sun would just be a mess of nines and zeros. With it, 92,900,000 miles. Crystal clear. And of course, there's more than one way to do it. The Indian system, for example, groups numbers into lakhs and crores, so the commas go in different places than they do in the international system, which uses millions and billions. The number itself doesn't change, but the tool we use to organize it, where we put the commas, adapts. It's all about creating a system to make big numbers easy to talk about. Okay, our second tool is all about seeing the hidden rules that are all around us. And the language we use to describe those rules, it's algebra. Now, don't let that word scare you off. At its heart, it's just a simple way of talking about patterns. And the secret ingredient to algebra is the variable. Just think of it like a placeholder. A letter like N or X just stands in for any number. It's a super simple idea, but it lets us write one single rule that can describe 1,000 different situations. It's incredibly powerful. Let's take a simple example. Matthew is 3 years older than his sister Neela. Now, instead of doing the math over and over again, we can just create one simple rule. If Neela's age is N, then Matthew's age is always N plus 3. And that rule works forever. If Neela is 4, Matthew is 7. If she's 8, he's 11. See? We've captured a relationship that's always true in one little expression. That's the magic. So, our third tool helps us compare things in a way that's actually meaningful. It gets us past just asking which number's bigger and helps us understand the relationship between numbers. And this is where things like ratios and data come in. A ratio is really just a comparison. A perfect real-world example is cooking rice. That 1-to-2 ratio, 1 part rice to 2 parts water, is a golden rule. It's not just a recipe. It's a rule of relationship. It tells you exactly how those two things have to relate to each other to get a perfect result, whether you're cooking for yourself or for a huge dinner party. Or look at this. A family spends 3 parts of their budget on provisions for every 2 parts they spend on vegetables. This bar chart makes that 3-to-2 relationship pop. You see it instantly. It's a tool that helps us see proportions and priorities, not just the raw numbers. And that brings us to our final tool, which kind of brings everything else together. It's the ability to tackle a problem with a clear, logical plan instead of just random guessing. This is the art of thinking systematically. So let's put this tool to the test. How many triangles can you see in this picture? Now, if you just start counting randomly, it's so easy to get lost, to count one twice, or to miss one altogether. The problem isn't the counting itself, it's that we don't have a system. So a systematic approach means we break it down. Step 1, we identify and count only the smallest individual triangles. Then step 2, we look for any bigger triangles made by combining those little pieces. And finally, step 3, we add them all up. No guesswork, just a clear process you can follow every time.
And by following our system, we land on the answer with total confidence. There are 5. We know we didn't miss any because our method was structured. And yeah, this is a simple puzzle, but this exact way of thinking, breaking a big problem into smaller parts, is how engineers find bugs in code and how planners organize massive events.
So, after looking at these 4 tools, taming numbers, finding patterns, making comparisons, and thinking systematically, what's the big idea here? What ties all of this together?
I think this quote just says it perfectly. Mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. All the numbers and the variables, they're just tools. The real goal, the whole point, is to understand. Every single tool we've looked at today is designed to help us see the world just a little bit more clearly.
And this toolkit isn't just for a textbook, right? It's for real life. When you're trying to figure out if you have enough time to run errands or splitting a bill with friends, you are using these tools. So the real question isn't whether you'll use it, but where are you going to put your math toolkit to work today?